All right, thank you for joining us on our next installment of Unit 4 Notes. Okay, what we did yesterday for cones, today we're going to do for pyramids. Okay, so a pyramid is a polyhedron that's like a many-sided figure, right? With one face that is the base, which can be any polygon, and the other faces, the lateral faces, are triangles that meet at a common vertex, sometimes called the apex. Yeah, apex predators. Okay. Like prisms, pyramids are named by the shape of their base. Okay, we already know that. Next. All right, a regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are congruent isosceles triangles. Okay, so look at this example here. Is this one a regular pyramid? No. So we're going to just say not a regular pyramid.
Not.
How did you know?
It is four sides. Oh.
It's four sides.
The sides aren't like.
They're not congruent.
Yeah, the sides aren't congruent. Do you see how the vertex isn't centered over our base? Like the center of our base? Okay, we don't have any information about if our sides are the same length. We don't know. Okay, but I can kind of tell by looking at it that it's oblique, that it's been like, you know what we did with the coins?
Yeah.
And we scooted them over. So this one will have the same volume as the regular pyramid, or the pyramid with the same base, but this one is not regular. So this one is called oblique.
Oblique?
Yeah.
If you think about your oblique abdominals, don't they kind of like crunch you over to one side?
Oh yeah.
What's an oblique about?
Isn't it
Like
these?
your side. Oh.
Yeah. Okay, so you can see here that we've got lateral edges, lateral face. We've got our altitude, which is a segment, and the height that is its length. And then we also have the slant height, which is similar to what we had for a cone. So it's going from the apex/vertex to the base edge, and it has to be perpendicular to the base edge. Okay? So what's happening here is that there are a bunch of different right triangles being made. Okay, so this is like Pythagoras' dream come true. All right, do you guys see that we have a right triangle here on the lateral face?
Yeah.
Okay, we got right triangles there. And then, if that wasn't enough for you, we have another set inside. Okay, we had this kind with the cone yesterday. Okay, so there's that one, and then there would also be this one over here. If this was regular, these two triangles would be congruent, but this one is not regular, so they're not congruent. Okay, do you see how this would make Pythagoras so happy? So when you're looking at these pictures and you're like, there's no way that there's enough information to find out whatever they're asking me to find out, you have to look for all of the triangles in the figure, okay? Okay. All right. So let's start at the bottom. We did our volume of a pyramid video. You're welcome. So we figured out that we could fit 6 congruent baby triangles inside of a cube, right? And then each one of those would have half of the height of the cube. So that translated into 3 pyramids of the same height, 3 congruent pyramids. So that's why we take 1/3 of our cube base times height. Okay, so it doesn't just work for cubes, right? We saw that for the triangular prism and the triangular pyramid, it was also 1/3, right? So any prism, you take the big base, the big B base, and the height, and then you divide it by 3. Okay, now let's talk about the lateral area. don't need to move. Okay. So the lateral area of a regular pyramid is half the product of the perimeter of the base and the slant height. Okay, that's a lot.
That is a lot.
So let's see if we can figure out where that comes from. So this one is regular. So that means that these sides are all congruent and that these triangles are isosceles and congruent. Does everybody understand what's happening?
Yeah.
Okay. So, what would be the height of this triangle? Yeah, this is the slant height. Okay, what is the base of the triangle?
One side of the square in this case.
Yeah, so is that just the side length of our base? Can we just call that S for side length? Okay. Okay, what about how many sides would we have? Well, it's just n sides, right? N lateral faces, n sides to our base, right? So the number of sides is n. Okay, so what would the area of one of these triangles be for the lateral area? Yeah, so we have 1/2 the base times the height, and what did we say the base was? Side length, and the height was the slant height, okay? And then how many of those triangles do we have? Specifically in this example, we have 4, but if we were talking in general for any base pyramid,
It's just the number of
it'd be n, right? Okay. Okay, so what would I get if I multiplied the n, the number of sides, times how long they are? What would I get?
The perimeter.
Yeah, the perimeter. N times S is P. Oops, I meant to have an equal sign. So do you see where they're getting this?
Yeah.
Perimeter times slant height?
The slant height. So the lateral area, oops, that needs an A. Lateral area is 1/2 of, you can think of it if you want like NSL, like NSA. Do you guys remember that? NAS?
Yeah.
Okay, and then you can say, okay, well, if I take the N and S and multiply them together, that gives me the perimeter. So it's going to be 1/2 the perimeter times the slant height. Now, if this was oblique, you would just have to add up the lateral surfaces areas, okay? There wouldn't be a cute formula because they're not all congruent, right? You know what I'm saying?
Yeah.
Okay. All right, so that's just the lateral area. If we want to get the surface area, we have to add the base.
The base.
The
Okay.
base.
So that base formula is going to depend on your base. Obviously, if you have a cute little square base, you just do side times side, right? Okay, if I torture you with a hexagon or a pentagon, you're going to have to do the 1/2 NAS or the 1/2 AP, right?
Right.
Okay. All right, cool. Let's flip. Okay, we need to find the exact surface area and volume. So we're knocking around.
That seems easy.
Okay.
Time for us to get it.
So we know that it's square. That means it's regular. Okay. So if this side is 12, what is this side?
12.
Okay, and what is this part of that side?
6.
6. Okay, so do you guys see that I have a 6 and a 10? I have one triangle right here.
Yeah.
This is a right triangle right there. Everybody see it?
Yeah.
So they're giving me the slant height. Do I need to find this lateral edge?
Not really.
Not really. I mean, could I?
Yes.
Yeah, but, okay. So what else is 6?
The distance from the center to the outside.
Yeah, so if this is 6, isn't this also 6?
Yeah.
Do you guys see it? Okay.
So if it says it's a square period, then it's not regular.
Yes.
7.
Say what now? I heard it start of a question. Okay, so this one is also 6.
Oh, I said if it says it's a square period, it's not regular.
Like
Yeah.
regular mean.
Well, provided that your altitude is in the center of your base. If your altitude gets scooched over, then your lateral faces won't be congruent. The volume will be the same, but I would have to double check about the surface area.
So we just have to assume that it's a pool.
Okay. I don't think I'm going to give you any oblique ones for the surface area.
Thank you.
You're welcome. Okay, so do you guys see our second triangle?
Yeah.
Okay. Our second right triangle is this guy. Do we need to solve for anything on this one?
The height.
Oh, the height. Okay. So I've got a 6 and a 10. What is it? 8. How did you get that so fast? It's a triple. So this is a 3, 4, 5 right triangle. It's just been multiplied by a scale factor of 2. Just got dilated by 2. You see it?
I do see it.
So if you can spot those patterns, it'll make you a lot faster than the Pythagorean theorem. All right. Now what? Do we have all the pieces that we need?
I think we do.
How many sides have we got?
4.
4. Okay, so n is 4. Should we start with some formulas? It says surface area, so let's do that one first. And then the volume should feel easy. All right, surface area. It's going to be our lateral area plus our base. So what is our lateral area?
One half.
Good. Perimeter times slant height plus our base is square.
All squared.
Yeah, so it's going to be our side squared. Okay. Now let's plug in our stuff. So 1/2 times our perimeter. So we've got 4 12s, right?
Yep.
Is that 48? The slant height is 10. The side is 12. Square it. Okay, what's 240 plus 144?
384.
Okay, so our surface area is 384. What kind of units?
Inches.
Okay, inches squared. It's 2-dimensional wrapping for our 3-dimensional solid, so it gets square units. All right, you guys ready for the volume? Okay, so my favorite thing to do is to forget the 1/3. So every time I do that, you guys can have a sucker. We'll see if that motivates me. All right, so the volume is going to be 1/3 times the area of our base times the height of our solid. So what is our base?
144.
Yeah, it's our side squared. So 12 squared. Oh. Well, I didn't forget it. I just miswrote it. Thank you. Okay, 1/3 times 12 squared times the height, which is 8. All right. I think I probably looked at that 1/2. Does your brain ever do that?
It's 1/2.
You guys are like, no, we never make mistakes.
1/3. Every time.
All right, what did we get?
384.
Is it really?
Yeah.
That's wild. What are the odds?
Oh my goodness.
Wait, so
That doesn't happen all the time. That's a fluke.
I'm a little confused about the perimeter.
Okay, talk to me.
So is the perimeter just the height times?
The perimeter is the number of sides for the base times how long they are. So I have 12 plus 12 plus 12 plus 12. So I have 4 12s. You see it? So it's not the lateral edges, it's the base edges.
Yeah, I think I did area instead.
Okay. All right, we good? Yep.
Is the volume ever smaller than the surface area?
Yes. So you can manipulate the dimensions to increase the ratio of the surface area to volume. The most efficient use of space is a circle. That has the biggest ratio of volume to surface area. But the more you squish it and make it flat, you minimize the volume and maximize the surface area. So anything like really flat or long and skinny will have a large surface area compared to its volume. Okay, the more square or like cubic or round something is, the more volume we get. It's more efficient packaging for the space.
Okay.
Does that make sense?
Yeah.
Okay. When you get to calculus, you'll do a lot of problems that do exactly that. So just stay tuned. All right. All right, we have to find the surface area and volume for this cute little square pyramid below. They're telling us that the height of the pyramid is 20.8 feet. Let's put that on here.
Yeah.
Okay, and the base's side lengths are, 34.62. I agree. I'm not a fan. Not about it. Okay, so what information do we need? We need the slant height. All right, so we got to find some triangles. Which one?
You make your line go over to from the center.
Can I go this way so it'll be easier to see?
Yeah.
I could go this way, but then it gets really crowded over here. So part of the art of this is figuring out where it's going to be easiest. So rather than trying to figure out where to draw your line this way, kind of eyeball it and see if you can spot the center of the side and then draw your, that would be the apothem, right? Draw your apothem over. Okay, so what is that length going to be?
Half of 30.
Okay, which is 17. Thank you. Okay, and then our slant height is going to be this beautiful hypotenuse. So I don't know if that's a Pythagorean triplet, probably not, because it's not integers. So we're going to have to do it the long way. So we're doing 17.31 squared plus 20.8 squared equals our slant height squared.
How many decimal places do you
It's telling us the nearest hundredth at the end, so can we have 4 or 5?
have? 27.0606.
20, oops, sorry, you said 27 point what?
0606.
0606, okay, I can handle that. Okay, so some of the errors that I saw in this quiz were that if we got a side when we were doing the Pythagorean theorem, the leg was longer than the hypotenuse, or the hypotenuse was shorter than one of the legs. So just like, and that just comes from like plugging these numbers into the wrong spot in the formula, right? Do you guys understand what I'm saying?
Right.
Like, yeah, okay. So just like double check that your answer makes sense and you will catch those errors. So your hypotenuse should always be your biggest side, right? Like, right?
Yeah.
Okay. Hallelujah. Okay. So are you guys ready for some formulas?
Heck yeah.
Okay, heck yeah. All right, so our surface area is going to be our lateral area plus our one base. Okay, what is our lateral area?
1 half NS.
Okay. NSL. So the number of sides is
4.
4. The side length is
34.6.
okay, and the slant height
27.0606.
0606. So this is N, this is S, this is L. Together, these two make our perimeter. Okay? If you want me in a good mood when I'm grading, label your stuff. Makes it easy for me to find everything I need to find. And when I'm in a good mood, I'm usually friendlier with the points. Just saying. All right, don't forget about my base.
34.63.
Yeah. Okay, so 34.62 quantity squared. Okay, so this is my big base.
That's a lot of.
All right, get typing. Let's do it.
Shut up.
That's a comma. What kind of units have I got?
Feet squared.
Feet squared. All right, let's do the volume. Okay, so for the volume, all right, we want 1/3 times the big base times the height. So our big base is what?
34.62 squared.
Okay, 34.62 squared, and the height was 20.8. All right, let's put that in the calculator. Okay, I got 8,309.91.
Yep.
What kind of units?
Big Q.
Okay, cubic feet, we got it. All right, we're ready. Okay, so many triangles. Oh my God. Okay. So we're going to find the exact volume and then we're going to approximate the surface area. Which one do you guys want to do first? Okay, surface area because it's harder. All right, so what do we need for the surface area?
The base. That's awesome.
Okay, we need the apothem. What else?
The lateral area.
The lateral area.
And the base.
What do we need to get the lateral area? And the slant height. Okay, so I can already tell what the perimeter is going to be, right? Because our N is 6. Okay. What do you guys want to tackle first?
Let's go with
The apothem or the slant height? Okay. Are you guys okay if I use this little triangle right here?
Oh, that's great. Yeah.
Okay, that's very convenient. You're welcome. All right, so do you see that that has 5 other buddies for a total of 6 congruent isosceles triangles in this base? Okay, what is the measure of that central angle? 360 divided by 6 triangles. So we get 60, but we chopped that in half with our apothem. So we got a 30. Okay. Remember when that used to be hard?
Yeah.
And now you're like, no big deal.
Yeah, it's easy peasy lemon squeezy. Yeah.
I could do that.
Squeezy.
I could eat apothems
You can
for
have
breakfast. Okay, so if the whole side is 8, what is this little bit? 4. And so now I can see that my apothem is what? Yeah. Okay, now we can tackle the other triangle. All right, they drew this one for us. They were nice. You guys see this one?
Yes.
All right, so what do we know on that one?
The bottom leg is 4 root 3.
Yeah, this bottom leg is also an apothem. So this little guy is 4 root 3. Does everybody see that? Okay, and then this height is 8. So can we Pythag that? So 4 root 3 quantity squared. Make sure you square the whole thing, not just the root 3. Plus, we're after the hypotenuse, right? So we're going to square both the legs.
Wait, why is it just not 4?
Can that be 16 root
Huh?
3?
Do you see that this is the same as that apothem?
Oh, yeah.
It's just rotated 60 degrees. Okay, so that gives us our slant height squared. What?
I got a 3.
I'm not surprised because when you square the root 3, the root goes away.
Oh, yeah.
So 16 times 3 plus 64
Yeah, 112. I mean, that's really good.
power. Okay, so it's okay.
That equals 10.5.
Can we simplify that into simplified form? So we're getting for the slant height the square root of 112. All right. I know that 100 is divisible by 4. I know that 12 is divisible by 4. What do you want to bet that 112 is divisible by 4?
A lot.
And 4 is a perfect square, which helps us a lot. Ooh, we got a 28. Guess what else is divisible by 4? 28. So if I can divide by 4 twice, I can also divide by 16. You guys seeing what I'm doing with this? Okay, so I'm doing 112 divided by 16. I'm getting 7. So this is square root of 16 times the square root of 7. What is the square root of 16 simplified to?
4.
It is 4. So I'm getting 4 root 7 for my slant height. Okay, holy moly, mustacholi.
Can we just keep it at root now?
If it was your final answer, you would need to write it as this. If you're just plugging it in the formula, I don't see any reason why you couldn't leave it as root 112. I don't think it matters. I mean, it doesn't matter to me. You might have a teacher in the future that wants you to simplify it, but I don't think I'm that teacher. All right, now what? Are we ready to go? Oh, let's just for thoroughness, let's put the side length up here. The side length is 8. All right, let's rock and roll. Surface area.
8.
Okay, 1/2 perimeter times slant height plus 1/2 perimeter or AP. Okay, perimeter is getting a lot of work. Okay, so the surface area is 1/2. What's our perimeter? 48. Times the slant height, which we said was 4 root 7. Plus 1/2 apothem, 4 root 3. Times perimeter, still 48. Okay, can we just agree that 1/2 of 48 is 24? So just multiply, just use 24, it's fewer buttons.
420.269.
Okay, and we want, do your notes tell you where to round?
No,
All right, can we just do 3 decimal places?
it's 269.
Okay, surface area equals 420.269. Okay, what about the units? Centimeters squared. Let's do the volume. That was so much fun. Okay, so we're gonna do 1/3 of our big base times our height of our solid. So that is going to be 1/3 times our big base is this guy, right?
Yeah.
Okay, that's big B.
Yeah.
Okay, now this one does say exact.
Yeah.
So we're gonna, don't multiply with the root 3, we're gonna leave that at the end. Yeah, so, well, I mean, 6 goes evenly into 48, so it should be fine. What's 8 times 4? 32? Is it 32 root 3?
30 root times 8. Times 8 again because of the height.
Oh, I forgot the height. Oh, shoot. I was so excited. So excited. Okay, so this is our big B. This is our height. All right, what is 32 times 8?
256.
Okay, yeah, I wouldn't have gotten that, to be fair. 256 root 3, what kind of units?
Centimeters.
Okay. All right, we're almost done. We're going to go through these last ones really quick. I want you to just really fast see if you could do them, and then we'll check in with each other, okay? I'm getting a triangle. What about the next one? Okay, let's watch the language.
He's been on my rear end all day. I'm sorry.
Okay, and then for a square pyramid, we're making a square base and then equilateral triangles as best you can for the lateral faces. Okay, was this better than yesterday?
Yes.
Oh, yeah.
A little bit.
No, I actually like this one better.
Yesterday was better?
Dude,
Except
that
for
was-
one problem.